level, that is product or assembly, that redundancy does not increase reliability.
System point of view, I was talking about system point of view. Okay, just I given one example. In the system level, suppose you ordered some kind of battery, okay, and if you are ordering a one battery high reliable, okay, and somebody is giving two poor reliable battery, which serves your purpose, because one battery fail, I have another power backup. So, but actually one reliability system individually, the battery is not reliable, okay, product is not reliable, but actually you are getting services, so you don't, so it is not visible to you, but individually one battery is poor, both two poor battery can improve the overall availability. In that context I'm telling. So that is the reason three matrices has been defined for the reliability engineer, RAM. Why MTBF? Because MTBF is not increasing, correct? MTBF by redundancy you can't increase MTBF failure rate. So failure rate MTBF is 8,000 hour, and this failure rate is 8,000 hour, and you want a failure rate of MTBF, and you demand the MTBF of 10,000 hour. So MTBF of 10,000 hours gives some kind of availability, and which can also give the 8,002. So redundancy will not increase the MTBF, but increase the availability. I'm
So
able to
in
convey.
case of a UPS, the case which you spoke about, let us say the battery MTBF is 8,000 and the
Yeah.
expected MTBF of a UPS is 10,000.
Yeah.
So in case we put two batteries,
Yeah.
the real system reliability is at the UPS level. It is
Yeah.
not
Correct.
at the
Yeah.
battery level.
Yeah. That is
So
that is, yeah. Got it. Got your point.
yeah, so still in case we have a lower reliability of the battery, the aim of putting two or three or two out of three in that UPS still keeps the reliability of the system higher than the product
Yes.
reliability which is at the battery level.
You are
So
right.
what I understand is you are talking that the system reliability does improve, but the product reliability still remains the same.
Yes. That is the reason that is the reason. If you are giving some kind of order for your system, suppose I'm designing a car. Okay. Now you understood correctly. I'm taking another analogy just to help everyone. I'm designing a car. Okay. The car having steering, engine. Okay. There are many component. Okay. Light, horn, gear. Everything has been certain kind of some kind of MTBF. Correct. Everything. And those systems are arranged in some order to each parallel this thing. So once we place the supplier, suppose I'm the car manufacturer, I'm the Maruti. So Maruti is the integrator. Maybe brake he's considering from some other company. Okay. Gearbox some other company, and they are putting in some assembly. So Maruti is putting MTBF of this. Every component level, some failure rate MTBF is specified. That's why otherwise they have to specify the component level failure rate and subsystem level MTBF, so that overall availability will be increased. Okay. So doesn't means he can give two gear, three gear. He can't give two gears. Okay. So this is the complexity in that sense. Redundancy is not increase the reliability of those product, but overall system availability can be increased. I'm able to
Yeah,
convince.
so sir, in the case of car, in case you take a manual gearbox versus a automatic gearbox,
Okay.
the gearbox is at that system level, I would say. Yes, in case we are only talking about the gearbox.
Mm.
So the aim of preparing a automatic transmission other than the function or the how it works is
Yes.
that the automatic transmission is supposed to be highly reliable,
Yes.
right? But the
Yes.
number of gears are same.
Yes.
So it
So
is the way they are placed, and the system is produced in the way that the same kind of gears which are placed in a different way and they function in a different way, the reliability increases.
wonderful. So this is the crux of the whole story. We called it the suppose you have automotive, everybody understand. There are many things, transmission system, infotainment, gear, box, horn, everything. Every systems, suppose one system also fail, your car is unreliable. Got it correct? You're unreliable as user point of view. Yes or no? Correct?
No, sir. In case no. So in case we say that, let us say number one gear fails, right?
Hmm.
We can still start the drive from number two, because it
So,
might take a bit of change of how to drive it, but
again, the same thing happen. Since it's very interesting conversation is going on, so it is unreliable because you have given them TVF while specification. It should not fail in first month. It is irrespective that we are getting our services in rail industries. Okay, as operator, I'm Indian Railway. I have ordered many things, many fun. I have already make a provision. Okay, that if something goes wrong, I will make sure my end user will not get affected. But as supplier point of view, I can put penalty on you. Why your door has failed? Because I wanted your door should not fail 1 month. It is irrespective. Even though your door is fail, I am managing and running the train.
yeah. So let us take, sir, the example of a train. I just like to ask you, for a normal Indian railway engine,
Mm.
how many kind of brakes are there to stop a train?
So there are railway. So there are two brakes. One is service brake, one is emergency brake. Okay.
Right.
Service brake means
So
okay. Yeah.
yeah. So now let us say a service brake fails,
Mm-hmm.
right, for a
Mm.
train.
Mm.
Still, the train can be stopped by the other way,
Emergency
and
brake.
the function of the train braking is to stop the train.
Yes.
So in case we look only at the service braking system or the that level, yes, the reliability is lower.
Yes.
But then in case we take that redundancy of the service brake and the other brake, so the reliability of braking is over and above what is required. So
Yeah,
my,
that
my
is
only
yeah.
request was to understand, is it at the system reliability or at the product reliability?
It is a product
Because at
reliability. Product
yeah,
reliability.
so yeah, so that is something which I agree. And also in the software reliability, surely redundancy does not increase reliability. Your statement there is right, but
Yeah,
overall what I believe
absolutely,
is this
absolutely.
myth is
No,
incorrect.
no, no, no. It is absolutely right. In software, see redundancy, in software reliability, I have a session, and I would request here you park this question. This is a very good question. I will explain you how software reliability can be improved, why redundancy is not there, what is the difference between redundancy and diversity. So that is a different subject. But hope you convince up to extent what I want to convey. Okay. Next question, please.
Sorry, sir. For this statement, I am not convinced. So no problem. But I
No,
understood it
no.
at a system level.
Yes, system level. Okay. System level because redundancy never increases reliability. I will again put some in different sessions software reliability point of view. Maybe you can understand. Okay.
Sure, sir. Thank you.
Okay.
Thank you very much.
Next. Any sir? Any question?
I am audible, sir.
Yes, please, please, please. I'm audible.
One question, sir. Real-time system are considered more reliable. So, what are the measures taken care of or we have done to improve the more reliability on these type of systems, real-time systems?
So real-time systems. One is the real-time system. One is the online systems. Okay. The real-time system and online systems with respect to software you are asking.
Yes, sir. Real-time system, real-time operating system we are talking about, which are more reliable and for time constraint we use these systems. For reliability, what measures are taken care of in the system?
So first of all, the first principles for real-time systems is the yesterday some context came. Redundancy is one thing, but redundancy is not like that. Suppose let me draw a diagram. You know, you have heard about the N version programming. You know, one N version programming. This is the one module of software, module A. Okay, and there are multiple module B and module C. Okay, B and C. So all modules having same functionalities, all are controlling some kind of maybe traffic control signal, something real-time system, avionics, traffic control signals. Okay, so these modules has been developed for same functionality, but different platform, different environment, different programming language, different company, different testing environment. So we call this is redundancy. No, this is not redundancy. Redundancy is a kind of a standby system. Suppose I have a same kind of two UPS, same kind of two UPS. We call the standby redundancy, we can say. But the probability of this and failure of probability of this and probability of failure of this was same, because both are same system. Because same kind of design, same things here. But in this case, probability of failure is different. So we call it diversity. In real-time systems, we can achieve the first principle, we have to use diversity. Okay. Similarly, there are many principles in real-time system, how to design real-time software systems. Okay. And real-time system, most of the systems, if it is risk-based safety, there is another principle. So software reliability, I will cover those things, how to improve reliability. The first thing is the diversity, which is the one step beyond than the redundancy and standby system. Okay. Next.
Sir, I have one more doubt. Is it possible to hack the real-time systems? If anyone hack these traffic light controlling of this traffic light, or in one movie it is shown that one hack the aeroplane of real-time system and control that one. So is it practically possible or
See,
not?
so, okay. See, another thing. See, the forum is very good. See, again, I'm very happy people are interacting. But this morning, I covered. Please listen, everybody. Reliability, safety, quality. Correct? Yes or no? Then, apart from this, there is a subject called the security. So security is different subject, and safety is different subject. Safety and reliability both are same in some extent. Safety and reliability. So let me tell what I want to convey. Please, everybody, listen very carefully. Okay, otherwise you will miss it. You understand? I have one environment here. Please listen, everybody. I request you. Okay, this is an open environment, and this is some plane is running. Plane. Okay, plane running in sky. And here is some intruders, terrorist. Okay, he want to attack the train, hack the signal. He want to make the fail that flight. So one thing, by some way he can destroy the signal, do something wrong activity he want to do. So first scenario. Second scenario, in the plane, some design defect happen, and plane crash itself because of some reason. So in both condition, system fail. So one way, if system fails by itself because of some anomalies, systematic failure, random failure, wrong design, stress. If system fail itself, this is the issue of reliability and safety. But if system is failed by someone intentionally, this is a security issue. So for security, this is a different kind of protocol, authentication, access control, other layers. So once we are working in real-time system, the first we have to make sure system must not fail itself. Like that, I'm healthy. See, sometimes because of my mistakes, my body kills myself, and somebody kills me. Both are different story. If somebody kills me, that is different method, and I kill myself with different method. So what I'm covering is the reliability and safety, how to make your system reliable and safe by your design. But also same time, what you ask the question, this is another issue. This is called the system security, service security, and one new cyber security. And the different protocol, different studies happen. So please don't mix those things together. Are you understanding? Everybody understanding? Security is different.
Okay.
Safety is okay.
Thank you.
Sir. Should I proceed? Okay.
Sir, can we use the terms quality of service and reliability to be
Okay.
same, sir?
I got your question. So again, same thing. So, this is some. So quality of service. Okay. You can correlate. I can help you. Maybe see quality of service, QoS. Okay. Quality of service. Okay. The quality of service is many attributes. Okay. Let me take railway example. Okay. Very simple way, very light mode. I'm telling you. Your train is coming on time. Delhi Metro. Oh, very good time. Very good. Okay. Always, this inside very comfortable environment. Okay. Proper displays there. Okay. Punctuality, passenger comfort. Okay. And in case of any emergency, safety is also there. First aid is there. Maybe and price also. Suppose Delhi Metro, then say Saturday, Sunday, my fare will be less, and Monday my fare will be this. During the some vacation, it is the very high. No. So fare structure. So all are quality of service. Quality of service means fare structure, regulation, safety. So quality of service is a very big activity. And among which punctuality, I'm taking punctuality on time. It's a reliability issue. Train, 10 o'clock is coming. Safety issue, train is not derailing. Safety issue. So quality of service is the array of activity, among which reliability and safety is one of the most vital activity, which is a part of quality of service. Correct?
Yes, sir. Yes, sir.
Yes. Boss, if you allow, we can go. Correct? So, okay.
Yes,
system,
fine.
okay. System reliability. So now, this morning we're talking about the reliability, system reliability. So system, subsystems and component are arranged according to specific design in order to achieve the output. Like UPS, there may be some switch, there may be some wire, there may be some battery. All together we assemble and make the UPS done. And this should be some performance and reliability measures. System can be modeled for reliability and also using some diagram. We call reliability black diagram. Why? To calculate the reliability, to predict the reliability, to improve the reliability. Suppose it is not coming, we will add one more component. We will add more hour wire. If this wire fails, this wire will go. For comparing different kind of models. Okay. So system performance and its reliability depends upon the type of component used, their qualities, and the design configuration in which they are arranged. Suppose you make a UPS, so what kind of battery you are using? The battery is very good, but the kind of switch, always switch is very poor quality, or wire is always short circuiting. So number of component, how they are arranged, their quality, all together will make the reliability. The modeling of system should be initiated as soon as some design diagram is available, high level design, and you make one design, you make one model, you compare the model, you check it, oh, it is not improving, then again you change it. So this kind of, we can update it. So like this system, subsystems, assembly part, this way we can do it. Okay, a very common thing. This is a class 5 standard knowledge. Okay, how to every system has been arranged. There are two types of system: non-repairable and repairable system. Non-repairable system means we can't repair. Okay, if fail is fail. We call the no maintenance required. For this we are using the MTTF. And repairable system, we can repair. It fail, we can repair. That's why we call MTVF. It fail, repair, fail, up, down, up, down. So normally during study, we more focus on the repairable system because most of the system are the repairable systems. Even though on non-repairable also we are studying. Okay, that is one thing. Some assumptions: all elements of system either operating mode or failed mode. So we assume that if there are four systems, four component. Let me put the slide mode so that it will be easy for you. Okay, and okay, sorry. So suppose there are 5 systems, this kind of things. Okay, and all together component will make one system. All are series like that. So we assume that system either is working or not working. That's all. So two-state model assumption. Second, all elements are operating state initially. We assume that. Okay, states of all elements are statistically independent. It means if this fail, doesn't means it will depend on this. All are independent items. So we have some assumptions. Under these assumptions, we are going to model something. Reliability of all systems are known. Suppose what is the reliability of this? Suppose this is the resistor. Okay, this is the some kind of diode. This something this. So all systems we are connected and we make some kind of subsystems. And subsystems we can make is the two subsystems arranged will make the complete assembly. So at the component level, every failure rate and reliability are known. Now you can say, sir, suppose you are making one PCB, okay, and PCB you have seen there are many diagrams here like this way, okay, and some circuits are there. Every component level PCB, this is are some kind of, suppose I'm talking electronics equipment. So electronics product may be what kind of capacitor, resistor, diode, triode, there are many things are there. At the component level, all data are known to you. There are some standard. I think one lecture is planned for this session also. MIL 217, MIL standard and reliability protection. So this is the resistor. So what is the failure rate of resistor? And resistor also different type of resistor. Capacitor also different type of capacitors. So every component level we have some data. Okay. And suppose you know the data of this and all are arranged together. So how to say the reliability of this PCB? I want to find the reliability of this PCB using this diagram. So that is the session today. Okay. Failure component are influenced by environmental condition. Obviously, it is very important point to understand. Suppose I'm using, let us take very simplest way. I have a fan. Installed at my home. Okay. And failure rate reliability of fan is known. How? Because fan is having some kind of component, electrical component, and all electrical component are known to me, and this reliability is this. But if you install the same fan in some factory where temperature is very high, or you install the same fan in rail where the ground is moving and vibrating. Let's take bulb. You use the same bulb in your home, same bulb in your car, same bulb, same LED or some systems in your plane or train. So depending upon environment condition, different kind of stress is there, ground, vibration, temperature. So reliability is varying. When manufacturer are designing any systems, any component, they're considering all those things because you are developing some UPS, you know where it will be used. So all the condition we will testing and giving it to that. Okay. See, RBD we call reliability block diagram or reliability logic diagram. RBD indicates that which component in the system must operate without any failure for successful operation. Series systems, these series systems. Okay, we want this much load. The series systems, we have series system like this way. Means all component must work for system success. System, all system must work. System should be working. Here, all component must fail. System will fail, only all component fail. If one component fail, it will run. So this is the one example. Similar way, you can see RBD. RBD indicates which component must operate without failure. RBD development requires understanding of operational relationship, how they are going to arrange. Okay, so this have example. I have given another example for some kind of computer. Okay, this kind of things and series system. So we call the RBD, simplest RBD, and this is called the reliability graph. So any system you design, any semantics you are having, any systems, either mechanical, electrical, electronic, whatever. So we can convert those in terms of some kind of graph and some kind of modeling. So if you convert, you will find systems are mixed, somewhere series, somewhere parallel, somewhere combination, and that's why, and we can evaluate the whole reliability of your systems. This is the subject today. Okay. So series system, you can see here, series system. So I told you that we know the reliability of this is known, R1. We know it. It's known. R1 and R2. If two systems are in series, what is the reliability of the system? So this is simple system. Reliability of system is the you multiply simply R1 into R2. That's all. Very simplest. It's class 2 mathematics. 1 into 2. That's all. Now the question is how to find the R1. Suppose this is a suppose this is some PCB. In this PCB, there are many components. Okay. Suppose 4 components. Okay. Every 4 component has some failure rate, lambda 1, lambda 1, lambda 2, lambda 3, lambda 4, failure rate, you know. So all failure rate, some formula is there. So you find the lambda s, all failure rate, suppose I'm telling for example, lambda 1 into plus lambda 2 plus lambda 3, all lambda you sum together. You find what? You find the lambda s. Lambda s. Lambda s means this system lambda you find. Reliability means R1 is equal to e to the power lambda t. So you can find the lambda. So I'm not doing this. I assume that R is known. Okay. So for simplest way, if reliability of one PCB, one subsystem is known to you, and there are 5 subsystems, all 5s are arranged in a series. So what is the reliability of the whole system? This is a simply multiply. See, series system and component, simple, nothing, very simple. Reliability of series model shows the successful operation. All should be, see, the failure of any system will result the failure. There are n subsystems, the reliability of systems can be found like this way. So nothing to explain, very self-explanatory. I will not take much time. So RS is equal to 1 to n. N system multiply. For example, see, a series system consists of 3 components. The probability of component 1, 2, and 3 is being operational is 0.9, 0.8, 0.75. What is reliability? You multiply 0.9 into 0.8 into 0.75. That's how I find. Simple. Okay, similar way, same thing here. The key point is reliability of series system is a very important point to understand. This is a very important point. Now you understand the class 2 mathematics. A into B into C. That's all. If your system is series, all systems have some reliability. Suppose are same systems, you n to the power n curve. Okay. The reliability of series system is always less than the reliability of the least reliable component. See, in this component, there are 3 components. Which is the weakest component? Weakest component is the 0.75. So reliability is always less than the 0.5. This is the key takeaway. So reliability of a series system is always lesser than the weakest point. You know, become the weakest chain, reliability of the weakest chain. Okay. As the number of component increase, reliability decrease. Order to achieve system reliability, high reliability, the component reliability must be high, especially in system with many components arranged reliability wise in series. Maximum improvement. Suppose this reliability is 0.54. Okay, suppose, and I want to improve the reliability 0.64. How to do? So we have to improve which one? Weakest component we have to improve. So maximum improvement in system reliability will be achieved by increasing the reliability of the system with the minimum reliability. Okay. So series system have some advantage over design. Very simple system, minimum number of parts, consume minimum power. Okay, less heat, take less room, less weight, cheaper, build too easy, but it is the less reliable. Same, I will not take much time. It's a class, or you can go simply. This system R1, R2, R3. Reliability means this into this into this, finish. Now come to the next point. If reliability of system 1 is, in the above example, is improved by this much, then improvement reliability is how much? Marginal, 0.9292. But if improved reliability this much, 94, you will get more. So this is a way. So how to improve reliability? Suppose you're designing, you want to improve reliability, always focus on the weakest component. This is a design issue. Suppose system has 10 components, all are identical, same similar component. Reliability is the R power n, because all are component. That's all. Suppose you have the lambda. Lambda means system you don't have reliability, but you have lambda, failure rate of this. Lambda and lambda 2. So you sum together, you find the lambda s. Lambda s means this way. Reliability means each power lambda s t, and this way you can do it. Okay, this is the way series system you can do it. 5 component in series, each has been this kind of failure rate. So now we have the lambda 1, lambda 2, lambda 3, lambda 4, lambda 5. Okay, a repair time is this. What is the reliability and MTBF of the system? So first find MTBF. So lambda s is this, because the 5 series, 20 plus 5. Mu1 repair rate is 0.5. MTBF is the 1 by lambda s, 1 by this much hour. So you find the MTBF, you have MTTR. Availability means MTBF by MTBF plus MTTR, 98%. The formula same thing. Same formula. So I am giving some practice. Reliability diagram, no redundancy, unit A, unit B, MTBF, lambda, lambda 2, MTTR, something there. You calculate this. Okay, you can, this is self, I have calculated this way. How to find the MTBF, how to find availability. And this is a way we can calculate the assembly level, sub-assembly level, system level, subsystem level, and finding some kind of value, some matrices in terms of reliability, MTBF and MTTR. You can see again, series system, component 1, reliability is this, component 2, reliability is this, 3. As soon as we increase here, reliability you can see here, decreasing. So reliability, one component, this, system reliability, this system reliability component. How it is graph is showing. Okay. Parallel system, some theory, some assumption directly go to the here. In parallel system, components, units, if all fail, then only will fail. So R1, R2, these are systems. So system will fail. So formula is the RS 1 minus R1, 1 minus R2 for here. How formula comes? Let me say simple way. System will fail. Why system will fail? Let us say failure. Why system will fail? Fail means both will fail. Means F1 and into F2 both will fail. Correct? Suppose failure, both will F. See, don't note it. I'm just explaining you how it is coming. So F system, suppose it is FS. System is S. F1 into F2, both will fail. So what is the failure of this F1? Failure means 1 minus R1. This is a failure, correct? 1 minus R1. Here, 1 minus R2. Both will multiply. This become failure. And failure means 1 minus, whole 1 minus. That's why 1 minus, this is F1, this is F2. And 1 minus F1, F2 is the R. This is the formula. Got it? So both all will fail, then only will fail. That's why the formula is RS means 1 minus R1 into 1 minus R2. This is the simple formula. It's the same thing. Q, I have taken Q. Q for unreliability. Reliability. Q1, Q2. 1 minus Q1, Q2. 1 minus F. 1 minus F means 1 minus F means Q1, Q2. Q1 means this, and all these things. Formula. In this case, reliability is different. Number of encroach is increasing. So probability of C component being operational. Now same question I'm taken. Same question earlier. 0.9, 0.8, 0.75, and then parallel. Okay. What is the result? 1 minus 0.9 into 1 minus 0.8 into this much. It will come this much. Calculate. We don't have time. Now you can see here. Reliability of this system, the same system are in parallel. So reliability is 0.995. What is the highest component? 0.9. So reliability of parallel system is always better than the reliability of the strongest component. Same thing in different. Hope it is not, it's very simplest arithmetic. There is no mathematics, arithmetic. A into B into C. But what is logic here? Okay. So reliability of a system is greater than the reliability of most of the reliability unit and component. Hope it is clear. System is more reliable with more unit in parallel. Okay, but it is costly. Now, parallel series model. Parallel series model, you can see some kind of some are series, some are parallel. Okay, so some formula is there, but don't go on this. I will explain in very simplest way. Okay, this is from book like this way. Subsystem 1, subsystem 2. So these internally these are in parallel. Calculate this. This is calculate formula this and this. So now it becomes the 3 system in series. Simple. So some general formula is there, but is as good series parallel and different way parallel series. Like this here. See, suppose this system is there. DG, rectifier, battery bank. You want to solve it in cable. So first 2 and 3. 2 and 3 in series. You make X. Rx means R1 into R3. Formula series. Now it become X and 4 and this. Now this is parallel. Okay. We make like this. Y. Y means this parallel. Now it becomes series. This way we can solve whole complex system. We can decompose the whole system in different small piece and find the reliability of every systems and find the word system reliability. Like this way, example. R1, R2. This R1, R2, R3. R1, R3 is the parallel. This formula. Okay. Now R1 you can do this way and R1 into R2 into R3. You can find R3 is this. Okay. And R1 and R3 like this, you can calculate the formula. Mixed parallel systems. Mixed parallel means you can see some examples. You can solve it just to practice it. See, you can first make a series. So 6 identical units, all having reliability of 85, and find this. Just to practice it, I've already solved it. Just to save the time, you can this it parallel series. All the value you can verify and practice it. It will give some confidence to you. Okay. See, K out of M systems is very important. K out of M systems. So for that, I think Professor Vivek Srivastava, I request he can recommend some books like Charles Evelings, and some books are there where all formula are given. But once you understand the basic concept of reliability evaluation, those formula can be applied. So one is the K out of M system is very important. K out of M system. Like in somebody is telling the avionics, okay, aeroplane, there are 4 engines or 2 engines or 3 engines. Okay, plane will run if any 2 engine is working. Okay, so there are many systems in design. Safety critical system, real-time systems are designed K out of M system. It means there are 5 systems, any 3, like here 2 by 3, the 2 out of 3 system. System will work if any 2 systems is working, like that way. Okay, so this kind of system have different kind of formula. Like suppose in this case, any 2 system will work. What is the possibility? Any 2 systems, R1, R2, R3, all are working, system will work fine. R1, R2 will working, Q3 is not working. 3 means failure. R1, R3 will working, and R1, R2. There is some formula developed for this kind of system. 2 out of 3, 2 out of 4, 1 out of 2. Some kind of formula has been developed because in industry many are the system K out of N system. Okay. So like the 3 out of 4 systems. Okay, 3 out of 4 system means 1, 2, 3, 1, 2, 4, 1, 3, 4. This path. If this path will work, system will work. These are some formula how it has been derived. I can't help you here derive, but this kind of formula are available in the books. But this is a very useful way to understand the reliability. Series system, parallel system, mixed parallel, series parallel, K out of M. Okay, but all bases are the same thing. So this formula I have used. This is the 4 out of, this is the, what is the 4 identical units having the failure rate of this. Evaluate the probability of system surviving this 5 years if at least 2. This is 2 out of 4 system. 2 out of 4 system. Okay, so this is a probability. Okay, so this is the how to model the systems. Any questions so far, so that we can go for the redundancy?
Excuse me, sir.
Please.
Sir, as you said that as the reliability increases, the cost also increases. So if we want to make the cost-effective reliable system, whether we need to have trade-off between the reliability and cost?
So let us take the example here, series and parallel. Suppose this is the all are thing. All are suppose all are same component. Okay, all are same. Okay.
Yeah.
So sometimes what, let me take in different way. See, simplest way, series system is the very cheap, but parallel is costly. Correct. So sometimes first step we have to make something. How many system we can put in series? How many put in parallel? How to optimize? Second thing, suppose in series system, let us take series system, any series system here. You can understand. I want to simplify this series system. Okay, 3 systems are there. It's parallel.
Yes, sir.
Suppose this 3 system. Okay, 1, 2, and 3. Okay, so these 3 systems 0.4, 0.54. I want to improve the reliability. Okay, if we add anything, it will decrease. So I want to improve it. How we can improve it? Simply anybody can help me. Three systems are there, A, B and C. And reliability is 0.8, 0.9, 0.75. And whole system reliability is coming 0.54. I want 0.64. How we can do it? 0.64, 0.8, could be something I want to improve. How I can do it?
So we can connect a system in parallel to the one with 0.75 reliability.
Anything. So you want to say, suppose all are there, what we can do? I can put one more component here, 0.75. Correct? Maybe it will some improve. Correct?
Yes.
Okay. And all the components have some different quality grade. Other way also, 0.7 component I replace it 0.7, because the same kind of component is market, we can find it the same component with different quality, different processor. It is its reliability 0.8. So my point is, either you can use better quality component with same diode, same capacitor, they're available, like I'm using. Okay. So either you improve the quality of, either you increase the this, and either you can match mix. This is the way we can do it.
Sir, but in both the cases, if we use the high quality product, then again the cost will increase. And if we use the redundant component, then again the cost will increase.
Yes. So both now trade off. Suppose high quality product. So if cost will increase, but weight will not increase. High quality. If put 2 battery, 3 battery redundancy, see sometimes in industry, weight is very important. How many weight you are carrying in flight,
Yes.
because in flight and all these things. So sometimes you can see maybe poor quality component, maybe cost will be effective, high quality company costly, but weight will increase. So some kind of trade-off is required. Are you agreeing?
So, sir, it depends upon the application.
Yes.
Okay.
See, for avionics, even though costly, I want my weight should be at the limit.
Yeah.
Correct? So no, I don't have space to install those battery, five battery. I need only one battery, two battery only maximum. So these are the, if you go more details, there are many safety critical applications. Maybe down the line something more course will be organized by safety. I can show you some demo. Moreover, you can note this kind of question what I told you. Professor Hilal is coming maybe one day, reliability prediction. He will focus more detailed applications. But at this point of time, I think you somehow convince what I'm saying. Correct?
Okay, sir.
Yes. Any other? Please. So now we come to the any question so far? Question is there, but if something is blocking your thought, let me know. I will help you. And for software reliability, I will address many of the concern. Any question which is unanswered, okay, we will connect again. We will cover here. But at this point of time, if anybody want to put something, let me know. Otherwise, I will be moving on the redundancy. So the use of additional component or unit beyond the number of required for satisfactory application is the purpose of improving reliability. See, again, you can say, sir, you are telling improving reliability. Why you are saying reliability? It should be availability. Okay. So it's availability only. Just to in the lighter note, we are saying reliability has been improved by redundancy. But after studying the reliability subject, you should understand reliability cannot be improved by component level. System level I'm talking about. System level. Okay. Series system has no redundancy. Since the failure and parallel system is redundancy. Parallel system, chaos of one system, series parallel have some redundancy. Now you understand. If component have more than 2 states, then there is the optimal number of components which maximize the system reliability. Types of redundancy: active, inactive, hot standby, warm standby, cold standby. We call it standby system. In active, all redundant components are in operation and are sharing the load with the main unit. Means we have 2 standby systems, okay, and both are sharing the load. Like UPS systems, okay, power and UPS both are sharing the load. 2 UPS, one UPS fail, Both are sharing the load, all are active. Inactive, redundant component are not sharing any amount of load with the main component, and they start operating only when one component is failed, like genset. You have to go and switch it. Just power gone, you have to go and switch it. So both have advantage and disadvantage. In this case, first case, both are sharing load. It means the failure probability of both are same. Suppose one failed, that may also fail at the same time. Standby system may also fail because both are sharing the load. Second thing, both systems are working, so they are sometimes wear and tear is same. With respect to time, both are working. But in this case, system is not sharing the load, so probability of failure is lesser. But problem is the switching time is more. Hot standby is like the active only. When failure rate of standby system is same as the main unit. Warm standby when the failure rate of standby unit less than the main unit, and cold standby when the failure rate of standby system unit when it is not operating 0. So any kind of safety application, real-time application, we are always using the hot standby because we don't depend on this. Both are working, all these things. So this kind of redundancy is the, so depending upon your applications, depending upon your, what kind of criticality, what kind of failure you can, suppose you are linked with server and which you want to always up. So for you, different kind of redundancy. So redundancy always increase cost, but depending on application, we can design standby systems. So redundancy allocation series system to determine the minimum number of redundant components that can be allocated to series system so that reliability can be achieved. So how to improve? So just I said the series system, how to increase redundancy. Doubling is defined by placing the identical component in active redundancy. In series system, doubling at least least reliable component. So how to improve the reliability by redundancy in series system and parallel system? For example, a series system 1, 2, and 3 and their reliability are this. Determine the minimum number of components which can be added in parallel to the initial component such that reliability becomes the 0.82. So if you calculate reliability something, how to improve? This is the question. So this is the redundancy, standby systems, series modeling. Now I'm open for the question because I was advised that 9:10 you have 9 o'clock you have to finish and open for the question answer. So now I'm free and we can discuss any questions, any kind of questions, any confusion so that we can take up it. Sir, are you there?
So can I say that when I decide that what kind of reliability is required for my system, is it based upon the risk?
So there are two things I can correlate with respect to railway. Okay, with respect to railway. So one is the risk, we call the safety aspect. Okay, and one is the performance. The safety and performance, two things are there. Like in the train, coming on time, running on time. Okay, but never accident happen. Okay, it is safe completely, but sometimes it is not good, no? You don't want because you don't know, like you are booking Ola and Uber. Okay, booking coming 5 minutes, but it's coming out of 20 minutes, sometimes half an hour. So it is no risk. It is no risk in the booking cab, but it is giving the discomfort, unreliability, goodwill. Are you agree or not? So risk is another subject. Risk is another subject because risk is mandatory. Because risk is linked with some kind of regulations that I will cover in some other topic. Okay, we call the safety systems are different story. But if you are coming train on time, you are not reaching, you have connecting flight in a flight. From here you have to go here. From here you have to go there. You have to connecting train, connecting flight. So there is no risk, but in comfort. So reliability considerations are specified in different parameters. Okay, in goodwill, comfort, punctuality, mean time between failure, average delay. See, nowadays Indian Railway also publishing data. So now 90% train on time. Correct? You know, once you travel by Indigo, they are saying being on time you are first priority. Correct? So safety is another subject. It's a mandatory, but reliability is different subject. Tell me, please.
Like sir, if I have a mission critical system and somebody asked me that what kind of reliability is expected from it. So what are those parameters based on which I can classify my, or basically on which I can calculate the value for my system?
So mission critical systems, reliability of safety function is different. See, try to understand. There is a different kind of matrices. In mission critical, safety critical systems, there is a concept called the safety integrity level, SIL, SIL product. We call the SIL rated product. Maybe you have not heard. What I request, you can note in your book somewhere, SIL, SIL. What is the SIL meaning? So all the mission critical avionics, railway, and any name, medical devices. So we call the SIL as a safety integrity level. So their MTBF and all this is different thing. It's a lighter note. The main thing is SIL rated system. How to achieve SIL systems, that is a different story. All the braking system, signaling system, medical devices, automotive, nuclear power, SIL is there. The SIL concept is different subject, and we call it functional safety and SIL. So SIL is the, I can't cover, but I can give you the term. You go and find some related identity. Okay, so safety integrity level. There is 4 level, 1, 2, 3, 4. 4 is the highest. If your system is still 4, it means it will not fail till 1000 years. Okay, I will come.
Sure, thank you.
Okay.
SIL will be covered by tomorrow. Dr. Verma will cover this topic.
Oh, great. Oh, good. I think you can ask. He's a very renowned professor. I also learned many things from him, so you can discuss SIL. Yeah, wonderful.
Yeah.
Good. Yes, please. You can discuss other things also. We can correlate. I think good platform to learn something. Okay. If everybody is here. Sir, please advise what to do. What is the next activity? Yes, Dr. Suchi.
Yeah, so actually, I'm not an expert in this area, but I had some very basic question.
Yeah.
Yeah. So, sir, if I'm to analyze a software and I'm asked to uh, I'm asked by someone to just have a rough estimate of what will be the expected time of failure for that software. What all would be the inputs that I would require to give that estimate? If you could just give me some idea of that.
Okay, so suppose you are designing a software. Suppose you are designing a similar kind of maybe food delivery software, Ola software, payroll software, correct? And before deploying into the field, you want to check internally what is the probability that the software will fail in 1 year, 2 year, 3 year. What is the probability of failure? What is the mean time to failure? Correct? Is your question?
Yes, sir. And to calculate that, what inputs should I be using?
So your question is again reframed in different way. How to predict the reliability of a software before it release? How to predict? So for example, let us take a very lowest level. I am designing any hardware product. Okay, hardware things. Okay, I'm designing my house, simple things. So reliability of this house depends upon the design is different thing. If it's a design, they have to design the quality of material, what is the metal you're using, what is cement and bricks, correct? In similar way, in software, there are many ways. The first basic way, the matrices, there are many matrices used. Okay, matrices used for the software reliability. For example, I think I have one session on this. Okay, the basic questions should be, what are the matrices of software? The matrices of software, you can say, sir, line of code. Okay, design complexity, psychometric complexity, requirement, number of requirements, because software is the number of requirements, number of inputs, huge inputs. So there are certain matrices. Like, see, what is my matrices? My height, my weight, my color, these matrices, my qualification. So my qualification. So some matrices is relevant to my education, my matrices, my qualification, my degree, my papers, publications. This indicates my reliability of publications. Similar way, my height and weight doesn't impact on this parameter. In similar way, in software, there are many matrices. Which programming language you develop software? How many line of codes? Who has developed? Who programmer has developed? It is developed by the experienced person. So for any software, there are a number of matrices I explained to you. In terms of size, in terms of complexity, in terms of an application environment, in terms of company. Among those environments, some matrices are relevant to the reliability. So the concept, the answer is simply way, what are the reliability relevant matrices? Like I am taking some interview, select my professor. Okay, I will ask, okay, 10th, 12th mark sheet, where you did PhD, oh, how many publications, how many patent. So these values will give the reliability of the professor in terms of academic qualification, correct? Similar way, in software, there are many matrices we call reliability relevant matrices. I request you note down your questions. In my software reliability sessions, I will show the matrices. Those matrices are used to calculate the reliability of software along with the application development environment. At this point of time, I think you are satisfied what I want to say here, right or not?
Yes, sir. I'll be waiting for those
You got,
reliability relevant matrices. Yes, sir.
yes, you got the what I want to say. That is reliability relevant
Yeah.
matrices. What is this?
Yeah.
And there are many things. There are
Yeah, I wanted.
many
Yeah,
things.
I want to know because some things are qualitative, like
Not quality,
developer
some
who's
qualitative. Some
yeah.
qualitative
So we would
also.
want to measure those.
There are qualitative
Okay.
also, quantitative also. There are many things are there. I have one book also, early software reliability prediction. Okay, I have written one book. Okay, I can share you one copy to you. You can read. Okay, and tomorrow, maybe day after tomorrow, one more session. I'm not sure, so I will discuss. But matrices based reliability prediction. There is another base. There is one way to predict reliability. Okay, there are many ways. Okay.
Okay, sir. Thank you.
Anybody else? You can ask any questions. Any branch, I think, reliability point of view, any mechanical system, electrical system, software system.
So
Okay.
we have already shared a timetable for the next week. And your talk is scheduled on 21st and 22nd of February.
Yes.
1 hours per day.
Yeah, that is the specific on the software reliability, and
Yes.
where I will try to cover some of the questions what we discussed here. Okay. And hope I conveyed the message, because see, myself, Dr. Vivek, we have conducted this reliability course in 4 years. I did PhD, Professor Vivek PhD. So 4 years we have done reliability study and all these things. I try to minimize in very simplest way, just to convey the message. So hope it was done.
There is another questions in chat box by Mrs. Sanjeev. How is reliability defined in industry? What is primary metrics or KPI commonly used?
So which industry? See, every industry has own KPI. Let me tell simple way. See, if you academic industry, if you're joining, their KPI is how many CI general, How many? There are many things are there. I don't know how many. I don't know. I'm not academic, but I have seen. So depending upon those matrices, I can see some impact factor and some point is given, and you can. Similarly, if you go to industry, there is different matrices. So reliability in avionics has different matrices, different way to define. So one is the safety critical industry, one is the general purpose industries. Every industry has different kind of way. Maybe in that day I will discuss. Okay. I don't know how to answer you, but there are many matrices. In railway, I saw the punctuality and SIL. SIL is the safety matrix. Without SIL, I can't do any work in the safety industries. So if you have any specific industry name, then I can help you in automotive, medical devices, transportation industries, and software industry.
I think Mr. Sanjeev is there.
Yeah, basically for the automotive industry, I wanted to know.
Okay, so for automotive industry, there is one standard. Okay, I can put in chat, but Asan, you can read ISO 26262. Okay, let me put in the chat box. Okay, ISO 26262. This is the one standard which tells about how to develop hardware, software for the car, any automotive. Okay, and they have given many matrices. Okay, and for safety point of view, they have given ASIL. The value is ASIL. ASIL. ASIL, there are 4 class: A, B, C, and D. Means ASIL means automotive safety entity level. So how to develop hardware, how to develop software, everything. And it is in the Google, if you find there is some soft copy, some primarily information, you will find it, ISO. Please read it. This is one of the most demanding industry in the future. If anybody has understanding of ISO 26262, you have get a lot of consultancy project. And anybody can approach me, sir, I know ISO, I can give you project. I can give you the project in consultancy, ISO 20. Okay.
So there is one note of appreciation by Sri Anil Kumarji that sir, you have presented the reliability in the easiest way.
Thank you so much. So
Thank
I'm
you.
not I'm not from the academic. I'm not a professor. There are many professors. You are also many professors. So I'm an industry person. So I assume that how simplest way I can convey the message to you in reliability. Okay. Thank you so much, and be in touch. And somebody asked question, risk analysis technique.
Yeah,
I'm not sure.
another question by Mr. Chhatrapal Singh. He is asking that can you elaborate some risk analysis techniques?
So risk analysis technique, I can't elaborate. See, can you specify the name you should ask? I can't elaborate now. Okay. So which industry you want? Again, risk analysis technique, different industry has different type of techniques. Okay. Tell me the industry name. Otherwise, please.
I want to note that this risk analysis topic comes in this reliability engineering or not?
It's coming. So there are two kinds of risk. Reliability risk means, see, again, okay, how to start? So many things are there. See, risk is very common word. You can understand. Everybody is listen. Risk may be business risk, health risk, okay, reputation risk, money risk. So risk is the project risk. So risk is a different subject. If you assign the safety risk, means suppose your train derail, somebody will die. This is the safety risk. Okay, like Chat GPT, do some mistake, Google, what the risk happen? Anybody die? No, but $100 million done, every risk. So risk analysis have a different meanings. Okay, so in a functional risk, suppose you're over voltage and somebody die, somebody happens, some derailment. For this, if you want to, those system risk, okay, system risk, there is a book, C.A. Erickson. It is available on the Google as well. Okay, book name is System Safety. System safety. You can read this book. Okay. On 23rd of, if I get some time, I can share one kind of write up, one presentation where techniques are listed there. And the common technique is the PHA, primarily hazard analysis, SHA, system hazard analysis, IHA, interface hazard analysis, OSHA, operational and support hazard analysis. These are the common techniques. Primarily hazard analysis, system hazard analysis, interface hazard analysis, and operational and support hazard analysis. These are common techniques used in the transport industry and many industries. And these are listed in the book. But I can't elaborate because time is not a very big subject. Okay, but definitely you can reach out to me. Okay, my mail is there. I can help you in any specific questions for you. Sarji.
Okay, sir. Actually, I was teaching software project management to my students, and in which there was this some subtopic risk analysis. So I was
That is
eager
yeah.
to
So that is different. That is different story. That is different. So software risk, there is the project risk, cost overrun, delay, slippage. That is different risk. The project control risk is there. Okay, that is the risk is different. Functional risk is different. Okay, so software risk. Okay, since you mentioned, maybe during my lecture I will cover one slide on that also. Software point of view. That's what I'm telling you. The subject is so big. So I don't want to confuse. I want to give the right answer and right form. That is different story. And this I have mentioned how to design the industry systems with nuclear plant, avionics, automotive, so that your system will not explode. It should run and function. So this is a technique. But what you ask, that is different story. Okay. So please ignore this my answer. For others, it is applicable. They can take it. But for you, it is not applicable. For software,
yes,
I
sir.
will cover.
Absolutely true. Depends on the application or what type of project we are doing. On the basis of that one, we will select the risk analysis, I think.
Yes, I will do.
Sir, you are giving an offline session on 21st. Is there any prerequisite? Like, would you want me to go through some stuff before I come, and
No,
then I
no.
can be an expert at ISO
The
26262, and we can have some consultancy in future?
Consultancy in future I'm available. So okay, consultancy I can give you. Okay, and I not in other way I can help you to take consultancy from others. Okay, so I can help you. You take consultancy from others. Okay, so prerequisite you available for 2 hours. Okay, listen, and there may be some keywords I will talking in that session, because everything is not given slide. Like today I also given many things. So after then we can discuss in 2 hours. This is the only things. And you are faculty members, definitely you can grasp very fast. Okay. So no prerequisite. I will explain in simple way. It will be clear to everyone. Sir, I'm on time. 9:30 is done. My train is on time. See.
Thank you, sir. Your session, today's session was very informative, and it's very.
Thank you. I'm honored. I'm glad to hear at least people are interacting, and that's why my requisite it should be interactive.
Various technical terms and knowledge and information that we have first time listened. And I am very thankful to Professor Vivek Srivastava sir for giving us opportunity for listening and take knowledge from this session. Thank you, sir.
Wonderful. I'm always here. I'm very punctual in time. I'm very punctual in the cloud. Any queries from onwards also you can discuss. Okay, we will do. Okay, no problem. Okay, sir. So please, thank you so much for giving me opportunity to interact so intellectual people. Very nice people are interacting. Very a lot of questions. I think even though some of the questions are not completely answered, people not very much convinced how redundancy can improve the reliability. I will again reiterate in different tone, maybe in the next session. Okay. Thank you so much. Sir, you are in mute. Vivek, sir, you are in mute.
Yeah. Thank you, sir. Thank you very much for your time and the way of expression that everyone is getting the words, the informative sessions, whatever you have delivered and covered in the different way with the industry perspective. Definitely, it will be useful to all of us.
Thank you, sir. Thank you. Thank you, everyone. See you again on 23rd.
Yeah. And